setup to racing teams. We work a lot in the hydraulic weight area, aircraft weighing as well, and then construction measuring force. So just like I said, a few bite-sized chunks of where T24 really shines. So our products, in a nutshell, the T24 range has an 800-meter range, line of sight, up to 5 years of battery life, depending on your resolution, your sample time, and your transmit time. We have a really wide range of sensor input types, ranging from strain to temperature, to current, to voltage, potentiometer, pulse, and running line as well. We have high integrity, error-free transmission data, low noise, high accuracy measurement electronics, and it's a really modular system. So a T24 system could be something really simple as one strain transmitter to one base station, and then running our logging software. And then you could expand from there. So in a nutshell, you have your sensor of choice. You then have one of our T24 transmitters. Then this runs into our sensor space, gateway, and platform. And then that is the deliverance of data up to sensor space cloud, which I will take you into more depth now. So remote management requirements. Really, we're looking at real-time data. We're looking at automated sharing across a business, looking into decision making, looking for keep equipment available and maintained at the right time. And we're looking at creating efficiencies to reduce cost. And this is why Sensor Space has been built to address all of these needs. So the key functions of Sensor Space, I've picked out some of the kind of like the highlights really of where we think our package really delivers. So for storage, I'll explain a bit more later in the presentation, but there's 3 years worth of data storage. When you get up to the 3 years, it works on a feed in, feed out method. Events, so there are a whole plethora of options you can choose to trigger events, and they can be from emails to text messages to webhooks to Slack messages. There is really powerful visualization within Sensor Space. There's great tools for analysis of the data that you have there, and then there is the ability to download all the data that is up within Sensor Space for further either visualization or for analysis kind of offline. So we'll have a look at a quick T24 and Sensor Space system setup. So it will show you a simple representation of the Manticore Sensor Space cloud system. We have 2 ways of gathering data from T24 transmitters. One is a standalone hardware device with up to 60 channels of input. The first version of this is an Ethernet connection up to the internet and therefore to the cloud. There is on the development roadmap to have a version with Wi-Fi and cellular. But as a workaround, what we've been doing recently, even though Sensor Space has only just been released, people are already asking for cellular gateways. What we found is that a client can take an Ethernet gateway of ours. They can then take a third-party 4G cellular modem and provide their own SIM card. They can hook the two together, and hey presto, you suddenly have a cellular gateway. But in time, we will be releasing a version that has a data contract all purchased through either ourselves or through Kuno at Sherborne. So the other way is our viewing and logging software called Log100. Once you team this with a plugin that we can provide, this can then send data to the cloud. The PC that's running Log100 needs to have a good connection to the internet. So they both send the gathered data up to Sensor Space at preset intervals, upwards from every 5 seconds. They both also have functions that allow them to send the max, min, or average data from the input since the last transmission. This means that you can have a relatively slow update rate, but you don't have to miss all the relevant data. This data is then stored for 3 years in Sensor Space as variables linked to that particular device. This data can be downloaded as a CSV file whenever required. Note that when you do delete variables within Sensor Space or devices, the data can be lost, so you've just got to be careful. but we can look into that in more detail if it's of interest. So the data can be viewed in user configurable dashboards. These consist of widgets. So the widgets can be as simple as a metric, which just shows the data or the last data received from a particular device. They can also be displayed on multiple trace charts and many other methods. So the event engines triggers such as SMS, email, webhook, and Telegram when preset parameters are met. This is not just a greater than, it can be the device has been inactive for X amount of time, or many other possibilities, probably too many to even fit this half-an-hour presentation. So these events can be set to be only active at certain times of the day. So what I kind of hope to show you here is that the modular system that we've built on from T24. So by the wonders of PowerPoint, you have your data source over here, which will be your sensor connected to a T24 device. Now that will either go through to a hardware gateway here, or it will go through the software plugin here. That will then deliver to the cloud platform and be displayed in your visualization or widgets. And then depending on the variables that you have set, that can then drive events via text message, email, webhook, and Telegram. So this is just a brief look here at our hardware gateway on the left-hand side, and then just a software plugin for Log100 on the right-hand side. So I wanted to include a use case. So this is a new product for us. It's been years in development, but we have a client who was an early adopter and they wanted to use it in a food production site. So what they wanted here, or the reason why they saw the power of sensor space, was for early warning of potential maintenance on the line, to reduce line stoppage altogether, to reduce warranty claims or disputes, to protect customer reputation, and a value-add service with a revenue stream. So this use case concerns a customer who was already using T24, now using sensor space in their application. So this customer is a leading manufacturer of conveyor and power transmission systems, who have had food and beverage customers who came to them wanting to know if they could measure the tension in a spiral conveyor belt system on a bread production line. So the brake has to go through a baking, a cooling, and sometimes freezing process on the same line, a bit like those holding patterns used in passenger aircraft on their approach to the airport. So the spiral conveyor follows a curved path and often reach several stories in height. So because of the curved path, one of the biggest challenges they face is tension. And this is under tension, they can buckle and break. So although the plastic modular belt made up of interlocking segments helps reduce this tension, the problem still exists and exacerbated by food particles from food becoming either lodged in the gaps between the plastic links. So the challenge here is measuring the force from the belt itself. More commonly, force is measured via the motor or the pumps. A traditional approach would involve a maintenance engineer going on site and carrying out repairs, and use a clip-on load cell which monitors tension on one cycle of the spiral. However, these visits can only take place periodically as part of scheduled maintenance. The conveyor has to stop. Plus, the load cell only fits on part of the belt. It's not designed to travel through the ovens and the chillers. So let's have a quick look at how we overcame this problem. So their choice was strain acquisition, which is one of our T24 SA modules. So the attraction was based on a couple of features. So it was the temperature specification from -20 to +55 degrees, and the actual physical size of the module. The PCB itself only measures just over 37 millimeters by just under 17 millimeters. And also its power consumption and radio range, so up to 800 meters line of sight, plus the ability to process the data to the cloud. So they also used a Modbus and ASCII gateway, which connected the acquisition module data to the PLC, which controls the conveyor. So temperature acquisition modules could have also been fitted to the system for correlation between force and temperature changes. So by the addition of sensor space, they used their Ethernet connection, which was already at the factory. And then this means that they could deliver data up to sensor space and then create their dashboards for preventative maintenance. So let's just have a quick look at some of the system. So they had the Ethernet